How do you build a solar system? The planets in our solar system were first observed thousands of years ago. Since then, we've subsequently studied their properties, and more recently even began studying the properties of exoplanets, or planets that orbit stars other than our sun. We can see how all of these planets look today, but what still eludes us is how they first formed. While we don't know the timescales of planet formation exactly, it's thought to take place over hundreds of thousands to possibly even millions of years. As such, testing any planet formation theories can prove to be somewhat of a tricky endeavor. We could look at meteorites, which are thought to be debris left over from the planet formation stages in our own solar system, but it's not clear how this applies to planet formation in general. Fortunately, powerful new telescopes, such as ALMA, located high in the Chilean mountains, are allowing us to probe planet-forming regions across the galaxy with a precision that's never been done before. Using this telescope, we can look at systems that are in the early phases of debris production and learn when stars start to host significant debris fields. My thesis focuses on one such system, creatively named HD 141569. I did not come up with the title. So this system is located about 350 light years away from us, around a 5 million-year-old star, and is thought to be caught somewhere between planet formation and then hosting a second-generation debris disk, not unlike the asteroid belt in our own solar system. Looking at this will give us a brief snapshot of its current stage of planet formation. So what I do in studying HD 141569 with ALMA is I'm able to weigh the dust and small debris in the system. I'm able to map the distribution of gases such as hydrogen and carbon monoxide. And I'm able to build a model of what its current stage of planet formation looks like. Now what I find in this model is that there's over 100 Earth masses of small debris, but not quite enough gas to claim primordial origins or left over from the formation of its host star. Instead, I find that the gas and the dust is completely consistent with second-generation debris production. This means that you can explain its consistencies entirely with disk interactions like asteroid or cometary collisions, and it's even stable over million-year timescales. So what we can infer from all of this is that we may in fact be looking at the youngest debris system ever observed, allowing us to study specifically how the planet formation process comes to an end. Constraining details such as these allows us to piece together answers to the question of how do you build a solar system? Thank you.